You're left with 11 by 10 here. Okay.
Yes, sir.
And this is x by 11 into 10. So therefore, what is the value of x? X is 11 into 11 into 10 whole divided by 10. So these two tens cancel. You get x is equal to 11 square or 121.
121.
So that is how you find out the value of x. Let us see the next question here, which is the number 19. You need to prove that 2n factorial by n factorial is equal to 1 into 3 into 5 up to 2n minus 1 into 2 to the power of n. So we start from the left hand side. Left hand side is 2n factorial by n factorial. Okay. Now see that 2n factorial is can be written as 1 into 2 into 3, 4, 5 up till 2n. 2n minus 1 and then up till 2n. I can write it this way. And n factorial can be
Yes,
written as 1, 2, 3, 4 up till, I can write this as up till n, right? Or what you do is you write, instead of writing 1 up till n, you keep this n factorial as it is. Okay, you can write also, no problem. Now what happens? All the even numbers odd numbers we'll separate, and the even numbers we are going to separate. So 1 into 3 into 5. This will continue till 2n minus 1 is odd. So this will continue till 2n minus 1. Okay. And the even numbers also we are going to separate. 2 into 4 into 6 into 8 up till 2n divided by factorial n. Okay. So now what happens? 1 into 3 into 5 up till 2n minus 1. I write as it is. And from here, from the second part, if I take 2 common from all this product, what am I going to left with? 1 into 2 into 3 into 4 up till n divided by, in fact, not 2, 2 to the power of n. Why? Because, because, see from here, this can be written as 2. This can be written as 2 into 2, right? 4 can be written as 2 into 2. 6 can be written as 2 into 3. 8 can be written as 2 into 4, and so on, up till 2 into n, right? Divided by factorial n. Now what happens? What you must realize here is that this comprises how many terms? This is how many terms? This is n terms, right? Because how many terms are here? When we had separated, this was how many terms? This one? This was n terms, right?
yes, sir. In terms.
And this one was also n terms, right? Because only then they can add up to 2n number of terms, right? So therefore,
Yes, sir.
this one is n terms, 1 into 3 into 5 up till 2n minus 1. This one is n terms. Okay. And from now, if you see the second part of the product, if you take this 2 out, if you take this 2 out, if you take this 2 out, this 2 out, and finally this 2 out, how many 2's are you taking out? How many 2's you are taking out? 2 into 2 into
5.
2 up till 2. You're taking out n terms here, right? From each term, you're taking out one 2. So how many 2's you are taking out? You're taking out n 2's.
N. N twos.
And what are you left with? 1 into 2 into 3 up till n. This is what you are left with, right? Divided by factorial n, which is 1 into 3 into 5 up till 2n minus 1. And then here 2 into 2 into 2 up till n terms is 2 to the power of n. right? And this,
Yes, sir.
what is this? This is again factorial n divided by factorial n. So what happens? This factorial n cancels. So you're only left with 2 to the power of n into 1 into 3 into 5 up till 2n minus 1. So that is your RHS. That is what you wanted to prove. That's it. A little bit of manipulation, and that is what is required here for this. Okay, let us now move on to the practical problems or the applied problems on permutations. Let us start with a very simple example of restricted permutation. Okay, okay. So let us see this very simple question here to start with. The question here is, in how many ways can the letters of the word radio be arranged? Radio. This word is there in which you have 5 letters. In how many ways can you arrange them? In how many ways can you arrange them means there are 5 places to arrange,
Hmm.
right? You have to arrange them in these 5 places. And how many ways can you do this videos? Clearly, you can arrange them in 5p5 ways.
Yes, sir.
Okay, 5 objects, 5 places can be arranged in 5p5 ways. And remember, 5p5 is nothing but factorial 5. Remember, I forgot
Yes,
to
sir.
mention this also. Note that the value of npn is always factorial n. Okay, so this can be arranged in factorial 5 ways. So this was a very simple question to start with. This was unrestricted permutation when no condition was imposed. Okay, let us see another problem here. This was 2 1. Let us see another problem here, which is um, 5 5, number 5. This is one is a example for restricted permutation. How many permutation can be made out of the letters of the word triangle? Okay, triangle. How many arrangements can you make out of the letters of this word triangle? So clearly, how many can you make? How many characters? How many places are there in which you have to arrange?
8p8.
8. So 8 places, 8 characters. So 8p8, which is equal to factorial 8. Okay, this
Yes, sir.
many ways you can arrange. This is without any restriction. Next question, in the next question it says, now this is a problem of restricted permutation. How many of these will begin with T and end with E? The question is, how many of these will begin with T and end with E? This is a restricted permutation. Now see, you have the word triangle. You have these 8 places here. Okay. So if the word begins with T, let us fix T here, right? And if it ends with E, let us fix E here. So we have fixed T and we have fixed E. How many are left? 1, 2, 3, 4, 5, 6. 6 letters are left. And how many places to arrange here? 6 places, right? And 6 letters in 6 places can be arranged in how many ways? 6p, 6 ways, which
6
is
ways.
factorial 6 ways. Is it clear?
Yes, sir.
So this was a problem from your restricted permutation. Now the problem number 6, if you see, how many different words can be formed by the letters of the word Malenkov? So that first question is, no vowels are together and the vowels may occupy odd places. So 6 1. Important kind of a problem. The word here is Malenkov. So how many characters are there? 8 characters. Okay,
Hmm.
8 alphabets. The first question is no vowels are together. No vowels are together. What does it mean? No vowels are together. First of all, separate the vowels. The vowels are A, E, O. Only 3 vowels, right?
Yes, sir.
Now the question is how many arrangement that you can make if no two vowels are together. Okay, no two vowels are together. 8 places. So you have 8 places here. 1, 2, 3, 4, 5, 6, 7, 8. 8 places are there. Okay, and if the vowels are never together, tell me how many consonants are there? What are the consonants here?
5.
Consonant. What are the consonants? M, L,
L, N,
N,
K, V.
A, V. 5 consonants. Okay, and how many places are there? Instead of going into places, now see here. Suppose I arrange the consonants first. M, L, N, K, V. Okay, arrange the consonant first. In how many ways can these consonants be arranged in these 5 places? 1, 2, 3, 4, 5. This can be done in 5p5 ways, right? The
Yes,
consonants in the 5 places can be arranged among themselves in 5p5 ways. What are the places that are left? This place is left, this is left, this, this, and this, right? Now each of these vowels can be placed in these places if they are if no two of them are to be together, right or wrong?
yes, yes, sir.
I can place the 3 vowels in any of these places. That means how many places here? There are 1, 2, 3, 4, 5, 6 places. And how many consonants? Only 3 consonants. So now the 3 consonants can be placed in these 6 places in how many ways? 6p3 ways,
Yes, sir.
right? So that means these 5 letters, these 5 letters can be placed in 5p5 ways. Again, the consonants can be placed in 6p3 ways. That means these 5 letters and the consonants can be placed in how many ways? And. Remember the keyword is and.
Uh, and means
Okay.
multiply.
That means this is factorial 5 into, you can calculate this value also, 6 into 5 into 4. That's it. Now multiply whatever answer you get. Understood? So
Yes,
this
sir.
was a case of restricted permutation. Let us come to the second part of the problem. The vowels may occupy odd places. Now, what do you mean by odd places? 6, 2. How many places here? 8 places, right? Eight places are there. Let us name these places. I've named them 1 to 8. What are the odd places? Odd places are this place, this place. This is odd. This is odd. How many odd places? There are 4 odd places here, right? Now, if these vowels are to occupy the odd places, then the others will occupy even places. How many consonants are there? There are 5 consonants. How many even places are there? This is 1 even place, 2, 3, 4. But there are 5 consonants, right? But there are 5 consonants, right? So I can make an even place here also. Suppose 3 places are occupied here. First place, third place, and fifth place, right? 3 places suppose
Yes,
occupied.
sir.
So how many places left? 1, 2, 3, 4, 5. 5 places. That means the
Yes, sir.
consonants can be arranged among themselves in 5p5 ways, right? and the vowels can be arranged in the four places in 4p3 ways. That's it. You understood what I said?
Yes, sir.
First, we place the consonants, the vowels in the odd places. But there are how many odd places? There are four odd places: 1, 3, 5, and 7. Okay, but only three can be occupied, right? So let us say that the vowels occupy three odd places, right? How many places left? Five places. That means now the consonants can occupy the remaining five places in 5p5 ways. So answer is 5p5 into 4p3. Clear?
Yes, sir.
So these are all restricted permutations. Okay, let us see the next one. This one, number 14. How many 5-digit telephone numbers can be formed with the digits 0, 1, 2, 3, 4 up till 9? Each number starts with 35 and no digit appears more than once. Now, this problem I would like to discuss in two cases. Here you have only one case, okay, but I would like to discuss two cases. First is there's something called as a repeated permutation, and there's something called as a non-repeated permutation. Okay, so what are the digits given? The given digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So question is how many 5-digit telephone numbers can be formed? 5-digit telephone numbers means you have 1, 2, 3, 4, 5. This is a 5-digit telephone number. Okay. If each number starts with 3, 5, that means each number in the beginning has to be 3, 5. So how many places left? There are only three places left, right? In
Yes, sir.
which you can arrange each of these numbers. But what numbers you have already used? You have used 3 and you have used 5. So you cannot use them anymore. Understood? This is what we call non-repeated permutation. You understood what I said?
Yes, sir.
See, a number can be like this also, 35035, right? Can be like this. We are using 3 twice and we are using 5 twice. But here, this is not allowed. Understood? Repetition of digits is not allowed. That means you cannot repeat the digits. There is another case of repeated permutation where repetition is allowed. Okay, that I will come to a little after this. Okay, first see the non-repeated permutation. So you have 3, 5 you have placed. So now you cannot use these two digits. What digits can you use? 1, 2, 0, 1, 2, 4, 6, 7, 8, 9. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 digits are there. And how many places are there here? 3 places. 8 digits you can place in 3 places in how many ways? 8p3 ways. Right? Right or wrong?
Yes, sir. Right.
So this is your answer. 8 into 7 into 6. Okay, whatever it comes to. So these digits. But the question is, but my question to you is that if the question was that that the digits can be repeated, then what would you have done? Can you tell me?
Repetition should be there.
No. See, 3, 5 we have already fixed in these places, right? That means you can use 3, 5 once again in these three places, right? In fact, you
Yes,
can
sir.
use all the digits in these three places. Now see, the first place, look at this place. In how many ways can you occupy this place with 10 digits? In 10 ways, either you can put a
10
0
ways.
or a 1 or a 2 or a 3 or a 4 and so on. That means in 10 ways you
Yes,
can
sir.
occupy the first place, right?
Yes, sir.
Next place, this. Once you have occupied this place in how many ways can you occupy? You can again occupy this place in 10 ways, right? This place again you
Yes,
can
sir.
occupy in 10 ways. So if permutation was repeated permutation was allowed, then you can occupy these three places in how many ways? 10 cube ways, which is 1000. See see the number of permutation, how steadily it grew from 8 into 7 into 6 to 1000. Understood?
Yes. Mm.
So that is why there's a difference between repeated and non-repeated permutation. Most of the problems that you will come across will be from repeated permutation. Okay, non-repeated permutation. Sorry, not repeated permutation, non-repeated permutation. They will mention repetition is not allowed. Okay, even if it is not mentioned, you will assume that repetition is not allowed. Okay, only for problems where repetition is allowed, they will mention specifically that repetition is not allowed. Okay, so you understood the difference between these two, repeated and non-repeated.
Yes, sir.
Okay, so then we move on to the next one. The next one here is number 15, very interesting problem, but I don't think I have time here. Okay, so I stop here for today.